Hey everybody, this is Larry. This is day 29 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's poem. So hope everyone's having a great weekend. The contest for me is in about half an hour, so hopefully we'll get through this and yeah. So if it's a little bit short, then my apologies, because it seems like this is 664 strange printer, which I think it's dynamic programming. We've been doing a couple of dynamic programming problems, but also I remember me being struggling a little bit with it. Maybe it's this one, maybe it's not, we'll see. But yeah, okay. So there's the strange printer with defining two special property. The printer can only print a sequence of the same character every time, yet each turn the printer can print new characters starting from and ending at any place and cover the original existing characters. Given a string S, return the minimum number of turns the printer needs to print it. So what is that? What is a turn? Go to the A and then go B. You go A and then print B from the second place, which will... What is a turn? I still don't understand what a turn is necessarily. Oops. Okay. So basic. Oh, so it just goes from like left to right and then right to left. Okay, so kind of like So it's not. A turn. Okay, I see. A turn is in like one step. For some reason, I read a turn is in like turning left or turning right or something. So okay, so every step we can basically print a substring. Okay. So okay, so I do remember this being tricky. I don't remember how to do it necessarily, but yeah. But I think this is one of those problems that if you struggle with certain parts of dynamic programming, this may be one of those beginning ones. The reason is that, I mean, there may be many reasons, of course. I don't want to be exhaustive about it. But one reason that I remember me, at least, Larry, struggled with for these kind of problems is because, and it took me a while to recognize this, is that the problem is not symmetric, right? And what I mean by that, it means that there are a lot of problems, a lot of dynamic program problems, especially when you're beginner, when you're starting out, a lot of them for whatever reason, and maybe that's just the property about it, right, is that they're symmetric. And what I mean by symmetric is that you can go forward in time or backwards in time and get the same answer, right? Like, for example, this isn't necessarily the shortest path, this isn't necessarily in dynamic programming, but let's say you have a shortest path. If you go from A to B, a lot of the times going B to A, you calculate backwards from B to A to B, and it's just like, it's the opposite, but it's the same, right, in magnitude or something like this, depending on how you want to structure it. So many problems are kind of like that, longest increasing subsequence is another one where, you can go longest increasing, but you can also just go longest decreasing, but going backwards or something like this, right? So there are a lot of problems kind of like that, but this is maybe the first times where it doesn't, right? Where you're not trying to figure out the first character to print, but you're actually trying to figure out the last character to print. Okay, I think that is the first observation, right? So you have to be careful about it. And then the last, or maybe not the last, but I think for me, the idea is kind of tricky. Hang on. I had my Alexa tell me to remind me to wake up because I was taking a nap before this for the contest, so it was just ringing. Okay. Yeah, I mean, this is definitely very hard, right? I think the first thing to notice, I mean, and there are kind of two ways to do it, right? And I think by symmetry, it should be okay. Because basically, one way to kind of minimize the search space is to always, is to make an improvement on a certain thing, right? I'm not going to go over it too deeply about left and right. Let's just do get min or something, left and right. The idea here is that we just have inclusive bounds because we're trying to calculate the solution for the substring that includes left and right from left to right, right? This is standard dynamic programming stuff. Today is a hard problem. I'm not going to go over this part just because this is not the emphasis on that part. Because also if you struggle with this part, you may struggle with a lot of, with the rest of this video. So definitely, if you don't understand how to reduce the space to do recursion based on the substring to just reducing it to the 2 indexes, urge you to kind of read up into it. Okay, so let's say you have this, right? How do we at least make some progress as an optimization? Well, if left is equal to right, then we can return 1 because, well, you only have 1 character, so you just print that color or whatever, the character rather, not the color. But if left is greater than right, then we can return 0, meaning that you have nothing to, your search thing, your string size is 0, so you don't need it. Keeping in mind that these are, the way that I'm doing it, these are inclusive bounds. So if some people may choose to use right as an exclusive bound, and therefore, you have an off by 1, so you have to change it around a little bit, right? And there are 2 ways to do it, I think, to make progress, you don't actually have to do this necessarily. It maybe is a premature optimization, but it's an easy optimization, I think, is that you can always draw the first character, which is S of left, right? Why do you do this? Well, like I said, because basically one thing that you want to do is to calculate the substring, and one way to do that is to you always want, this observation, maybe it's a little bit greedy, is that you always want to draw one of the edge characters because that we do, no matter what else you do, if you draw just like one, like for example, if you have something like this, you could draw A 3 times, but it's still better than drawing C for some reason and then drawing A on top of it, right? No matter what you do. So you always want to draw this. I think by the argument of symmetry, it doesn't matter where you draw the first character first or the last character first. I mean, maybe you can make it a choice if you really want to do another construction that way, but I think it doesn't matter just by argument of symmetry, right? Because basically, they don't, they could overlap, but if they overlap, then you just draw, basically, if there is such a case in which, let's say you have A, like A goes up to here, and then dash dash, and then like you have maybe B here. If you do want to draw something like this, and then if A is on top, then you could effectively just not draw the B, but if B is on top, you could effectively just cut off at A earlier. So it doesn't matter the order of whichever you do it. So I think from that, it should be okay to draw this, right? So then now you just brute force how long to draw the first character, right? You could draw for 1 character, you could draw for 2 character, ... right? So I think that should be good. Yeah. So basically now we go for naming things is still hard, but let's just say X, right? In range. So we want to start from. Let's just write this for now. We might have to change it a little bit. So I could keep explaining. Okay. Right. So the current character is this thing. Oops. And then now we want to draw this. We want to draw this from left to X inclusive, right? So okay, what happens when we draw this inclusive? And we have to be careful here, right? But yeah. Let's see. I'm trying to think whether this makes sense. How am I doing it correctly? So the way to do it is kind of divide and conquer, right? So basically you have this idea of get min from left to x, and then you have this idea of get min x plus 1 to right? So that's the dividing part. Here we're drawing all a's. I'm just trying to think what is the best way to kind of calculate this. I think the way that I'm thinking in my head is hard to explain. That's why I'm trying to think if there's a easier way to do it. But really, you can just break it down into chunks, right? Meaning that, okay. Meaning give me a second. How do I explain this? I'm also trying to make sure that the thing that I'm doing is exhaustive, right? Well, I think one thing to realize is that you only want to draw it to X if they're the same color. I mean, you don't have to, but I think that maybe is a good optimization, right? Man, this is hard though. Do I want to do that? Like, I feel like, do I need to do that? So basically, if s of left is equal to s of x, then now we can, I mean, this part is, this part is easy because we're not drawing over this part. I'm trying to think through what the implication of this part is, right? Because, you know, so this part is the part that we draw all the same character. These two characters are the same, which means that we get it for free. But I need another dimension. Okay, so this part is the part that is easy, but this part now, am I right? Because basically they could be all the same color, or they could be like alternating. There's a lot of cases that I'm just thinking through in my head. Because they could be like all A's, and then you want this cost to be 1, and then you have like A, B, B, and then this cost is more than 1. I don't know what it is, but this A is unclear whether you want it to be the original one. Like, do you want to split the B's into two groups or one B group and then print A again afterwards, right? And that's where the dynamic programming should handle, but I'm trying to think whether how to handle it within a good case, right? Like, how do we handle this in such a way that we get A's for free in a way, right? Oh, I see. I think I've been too. Oh wow, that is tough to come up with, and I don't know that I can always come up with this one. Okay, yeah. I mean, I did remember this is hard, but the idea is actually a little bit trickier than what I kind of showed. What it should be is that you have to use this idea of continuation, where basically you chop this off. Like, let's say you have something like this, right? Instead of just, we assume that everything inside, in this case, is going to be not in. So let's say A is left is equal to X, then we actually, instead of saying that, okay, let's just do some like funky thing where you have to pass in the current color, what you actually want to do is just say that everything inside we assume is going to, we're going to have a place where it has no state, and then we just assume that passing A forward we get for free, right? So you do something like this, because now it is inside, and then now you pass this part, because now you want to continue using the A but only for free. So we have to be careful about the off by ones. Right? Sorry, I'm still thinking. I'm just kind of writing out the other stuff, but is that true? Where did I do the +1? I don't even pay for this yet. Man, I am not understanding this right now. Basically, that's a tough way to do it. But then now we ate a character. I mean, okay, so this by itself would be the standard dynamic programming, right? What does that return? Oh, maximum recursion, because this goes, no, that would just, but then this would just be X, and if it's just left, right. Okay. So now this returns every character, okay. So we want to, So if the last thing that we do is character A, what does that mean? So we need a base case for sure. That's not infinity. We always want to do the first character, so let's just say that's going to be 1 is you're going to get min, left plus 1, right? Okay. But, yeah, also this is wrong now, sorry. We actually want to divide them into 2 parts, but basically what this is saying, why does this work? Right? We also only have like 13 minutes before I have to go do the contest, so I have to be okay, so basically the idea here, man, I am like blanking out on this for some reason, even though I'm getting the right answer of it. Should have done this after the contest, maybe. Alright. What is this saying? Why am I doing this? This would just be 1, but that means that I mean, so the core idea, which is kind of tricky, is that basically you're saying that this is saying that S sub x, and this is kind of tricky because the base case is handled in a way that is very tricky. S sub x is going to print as the same time as S sub left, which is what we said before. It's just that this recurrence is like so kind of confusing, right? Because the way that this is structured is that it actually goes backwards, and the idea is that we actually finally factor in the cost of S sub left when left is equal to right, when there's only 1 item left, right? So then the idea, the structure that this has, if you have something like A, B, like A, whatever, is that actually what this is saying is that S sub x, I mean, so this is actually what we said, which is true. So we're printing from S sub left to, or from left to x, I suppose. Left to x, we're printing S sub left, right? And it's just that the way this loop goes, you kind of think through the stack space, is that a little bit confusing, is that, okay, let's say, you know, we split up here, right? That means that here, everything here is going to get factored once, like we just go through A, and then actually, if you look at the recursive stack, let's just ignore the right side for now. What happens is that it may do something like, okay, and actually, this removes the x because now it's saying that S sub x is the same, so then we can actually remove it here, and then the recursion is actually this part, and then now it takes another A, maybe, and then it goes this, and then do a recursion on this part, and that's why there's no plus 0 or anything, or well, it is plus 0, but no plus 1 or anything, because the cost is factored in to the left, so that eventually this is going to return 1, or I guess this thing, even though, you know, you can just write this obviously as get min, left plus this, which is maybe slightly more, yeah, let's do it. Yeah, maybe that's slightly more readable in a way, but in the sense that we're trying to, you know, go over. So then now you're basically, so for every string, it is what we said, I guess. We're trying to calculate, we're printing from S to S, So another way of saying this though is that x is the farthest index we go here for free, and then you do a recursion back that way with respect to now. Okay, so now a is the last. So instead of saying we cut off here, this is the last index that we print here for free, and then now the recursion here using the repeated sub problem is okay. What is the next a that we want to use? Is it this one? Is it this one? And then you kind of just chop things off. So now you go from so now you have a substring. You're basically saying, okay, given that the first character is a, what is the, and then you kind of brute force chopping it off. So maybe that's the better way of saying it. But man, is it tough to kind of come up with? Maybe it's just experience. I kind of have, not gonna lie, like just cheated a little bit in that, like I kind of vaguely remember this. That's why I was like, but I don't understand it, you know? So, I don't know. But it's a very hard thing because you have this idea of reusing your base case in a way that is factored in, but not necessarily clear, right? Because now at a certain point, when x is -1, we'll get, because you can't skip, you know, because of whatever continuous whatever theorem, central value, I don't know, whatever it is. This will eventually go to left, and when it goes to left, this is just 1. So you have like 1 plus to get, and then you have all these summations, right? And then basically, if you kind of look through an input, so maybe it looks like this, and if you look at for an input, the ones are basically all the beginning of the substring that you're printing, or something like this, right? I mean, I'm showing an example. So if the answer is 3 and it returns, you know, here, then actually it just means that the optimal answer, if you follow the optimal path, will just it starts with a. You can actually get the parts where, you know, a goes to here, maybe, or something like that. So it's very tricky. Jeez, this is tough. It's been a while. But yeah, we did this part. I think this is right. But now we have to do the memorization. I only have like 6 minutes to do the contest, or to start the contest. So this may be a little bit rushed. But I'm doing the same thing I'm doing for every dynamic programming problem. So definitely, hopefully, watch an older video of mine. Or if not, then, you know, yeah, right. But yeah, I'm doing the same thing I do, so yeah, without just slapping on a cache. So yeah, basically we are just doing the memorization because all the inputs are the same. If for the same inputs we get the same outputs, so we can just memorize it. Let's give it a submit. Hopefully I didn't miss an edge case. Yeah. Sorry this end is a little bit rushed, but yeah. What did I do last time? I was actually thinking about doing it this way too, to be honest. I guess this way also works, at least in C. Apparently I did it so long ago in C. Yeah, I'm not gonna go with this one. The video is from, if I have a video, it's from 4 years ago, so it probably isn't even that good if you watch it. I actually was thinking about solving it this way though, because I think that this way is a little bit more intuitive for me. Basically, I'll go with this one real quick in case you want to try it for yourself. But this way, the states are given these substrings, and given the first character is k, or the last character printed is k. You know, just calculated, right? So that's basically the idea, and you kind of figure out the splits from that recursion, as I did the other way last time. But this one, it obviously works. It's almost like an inverse, what I call the loop, unrolling of loops. But it's very hard. I don't know how. I don't think I did a good job of explaining how to come up with this. I think I did an okay job. Maybe you disagree on the intuition and why it works. But my intuition today is not strong enough for me to like, hey, these are the steps that I take, because I think I just kind of, like I said, rely a little bit on an experience and playing around with it until I kind of got the idea. Because this idea of loop unrolling with dynamic programming, it comes up here and there, but this is a particularly difficult usage of it. I don't know. I have to go do the contest, so it's a little cut short. Hope this is okay. Or if it's not, it is what it is. But definitely leave comments if you have questions. Remember, ask good questions. Don't ask, hey, can you explain this but better? It's like, well, look, it is what it is. So if you have specific questions, ask here or the comments or the Discord. But yeah, that's all I have for this one. That's all I have for right now. Yeah, stay good, stay healthy, to good mental health. If you're doing a contest, good luck. I'll see you later. Good, take care. Bye bye. I have to find a button.